Hello and welcome to our presentation of heartbeat sensor using Raspberry Pi Arduino Nano and Seed Studio's Groove Beer Lobe pulse sensor. In this project, a Raspberry Pi is fitted with 3.5-inch resistive TFT touchscreen. An Arduino Nano is connected with the Raspberry Pi using serial port. So Arduino Nano is driven by the Raspberry Pi. Now Group Kit's pulse sensor is connected with Arduino Nano. It has got 3 pins and YOLO signal pin which is given to A0 and the black and red ground and 5-volt pins respectively connected with the ground. Let me explain you about the circuit. So this is a Raspberry Pi B which we have fitted with a 3.5-inch TFT touchscreen. This is a resistive touchscreen. Now what we have done is we have taken an Arduino Nano. And we have connected it to the serial port of this Raspberry Pi. Now this is a heart rate sensor module. This is basically a group compatible module. Now if you look at the heart rate sensor, it has got 3 pins. One is black, one is red, and one is YOLO. YOLO is for the signal, black and red for ground and 5-volt respectively. So we have taken this connecting wire to connect these pins with Arduino's ground, 5-volt and A0 respectively. So our circuit is Raspberry Pi, the Arduino Nano, and the earring sensor nodule. Now let me show you how this entire thing works. So all you got to do is, here is your ear plug. You need to just plug in this in your ear, preferably the left ear. So you can see the heartbeat module, the Arduino Nano and the Raspberry Pi combiningly keep tracking your heartbeat, that is your pulse rate. It shows all the variation of the heart rate. And 5-volt pins of Arduino. Arduino uses an interrupt services to register the pulse. Whenever there is a heartbeat, the group sensor generates a pulse. Arduino calculates bits per minute and interbit interval from the pulse occurrences. This data is converted into a comma-separated string and is sent to Raspberry Pi through serial port. A Python program running in the Raspberry Pi reads the serial port data and displays it on the real time. Now let's have a look at the overall project. So as you can see, I have logged into my Raspberry Pi's desktop using remote desktop using RDP. Now for the programming, we have got particularly 2 parts of code. One that runs for Arduino Nano and the other one which runs on the Raspberry Pi. Now I've installed Arduino in our Raspberry Pi device, which is slow but yet it's manageable. This is a standard pulse sensor code where pulse pin is analog pin 0 And there are particularly two parameters. One is bits per minute and one is interbit interval. Now what we do is we use the serial in port to transmit the data to our Raspberry Pi device at a speed of 115200, which even Intel edition and most of the high-end devices supports. Now we register for an interrupt. Whenever there is an heartbeat, the pulse sensor generates an interrupt. These two values, because we need to pass both heart rate and IBI, we convert them into string and separated by a comma, and then we send this to our Raspberry Pi device. The interfacing code is written on Python 3. Now we use MATLAB Plotlib for plotting the graph, and because MATLAB Plotlib is pretty slow, in order to obtain the graph and the rendering without blocking, we use the animation class of matplotlib. The animation function or matplotlib can be registered for particular intervals. We are registering this function for a particular interval of 100 milliseconds, such that after every 100 milliseconds this function gets called automatically. When this function is called, the system reads the serial data. After reading the serial data, it splits the data based on a comma, and then it separates two values. These two values are then been printed through two different axes. Now, Raspberry Pi's remote desktop support is pretty awesome, because even though it is little slow, it's extremely difficult to always test and program in the small screen. You can use PuTTY or any SSH software to obviously write your code. However, using remote desktop gives you the power of working with the device itself using editors like gedit. Note that if you are using PuTTY or any SSH software, the gedit is not available to you, and you have to be contained with nano editors, which comes with the Raspberry Pi. Now let's see, if you look at this, this is the same graph that you got in your device. So there is a lot of calibration, because the resolution of course your PC and Raspberry Pi varies to a great deal. Now let me make some movement. As I keep making the movement, you'll see that bit rate increases a little bit and then gets settled down. Interbit interval, on the other hand, shows how much is the variability from one bit period to another bit period. And as you can see that I stood up and I started moving, the heartbeat has started. The data also shows the time period for which your data has been captured. The good thing is that this is so very sensitive and so very the good thing is that it is so very sensitive and so responsive that if I remove my earplug, say I have removed my earplug, and the graph immediately stops. Now if I am putting my earplug again, as I have done now, the graph starts and it does not account for the lost time period. So it again starts accumulating the data. Now this data has been put in a file and saved in cloud for further analysis. I hope you enjoyed our demo. of Raspberry Pi and Arduino Nano based pulse rate sensor. Thanks for watching. Thank you.